Before I start today's problem, let me mention that recently SOA added 85 more sample questions to their list, taking the overall count to 570. And as those of you who already know about my book know that whenever SOA makes an update, I update my book accordingly. And so I've been working on these new sets of problems. And yesterday, by the grace of God, my updated version got published. As you can see on Amazon, now it has all the 570 sample questions. And in case you're not familiar with my book, you can watch the videos that are on the end screen of this video and all my other exam P videos, where I talk a bit more about how the book is structured. And you can also read this sample on Amazon. And I will again stress that if you decide to buy my book, you should always get the new one from Amazon, the one that is sold by Amazon itself, and never get a used one because the used one may still say that it's updated. It may give you the same title as the one you see for the new one. But once the book gets to you, you may find out that it's actually an older version and it may not contain all the sample questions. So the only way to make sure that you get the most recent updated version is to buy the new book that is sold by Amazon itself and not by a third-party seller. Okay, so with that out of the way, let's get to today's problem, 348. A policyholder incurs one loss under each of three policies. Each policy has a deductible of 30. Losses under each policy are uniform on 0 to 100. The losses are independent. Calculate the probability that the policyholder will receive benefits from any of the three policies. So what we have here is we have three policies going on, and the benefit will be received if and only if at least one of the three losses is greater than the deductible. So remember, the question was to find the probability that a benefit is received uh, from any of the three policies, which is another way of saying that at least one of the three losses is greater than the deductible, and that's the only time you will actually get some positive benefit. Otherwise, there's no benefit if you are having a loss less than the deductible. So let X be the loss amount in a single loss, and we are told that X is uniform on 0 through 100, and the deductible is 30, so that's the probability we are interested in, probability uh, X being greater than 30. So this is uniform distribution, so the probability of being greater than 30 will be 100 minus 30, the upper limit minus 30 divided by the upper limit minus 0, but minus the lower limit, which is the 0. And that gives you 0.7. So this can easily be seen if you draw a number line whose endpoints are 0 through 100, mark 30 on it, and mark the region that is greater than 30. So you will see that this ends up being the situation. And let Y be the event that a loss is greater than 30. We're interested in this event because that's when there is a positive benefit paid out when you're greater than deductible. And Y is binomial with n equals 3 because we are dealing with three policies, and the probability of success is the probability of getting paid or the probability of loss being greater than 30, and that is 0.7 as we calculated here. And so f of y according to the binomial PMF will be 3 combination y, 0.7 power y, and 1 minus 0.7 is 0.3, so 0.3 power n minus y, and n is 3. And we need the probability that there is a payout, which means there's at least one payout in among the three policies. And that would be probability y is greater than equal to 1. So you can do it directly because greater than equal to 1 will mean 1, 2, or 3, but still it saves you time if you go through the complement. So probability y is greater than equal to 1 equals 1 minus probability y equals 0. And that's 1 minus f of 0, and f of 0 from here. When you put y equals 0, 3 combination 0 is 1, 0.7 power 0 is 1, and only this part contributes. 0.3 power 3 minus 0 equals 0.3 power 3. So 1 minus 0.3 power 3 ends up being 0.973. That is choice E.